All right, I'm going to pick up where I left off within this first section of notes. So we've talked about matter, we've talked about energy, we've talked about how matter is identified, and now we're going to talk about when we put different atoms together. So when we have two or more atoms combined, we call it a molecule. When we have two different atoms that come together via a bond, we call that a compound. So with chemical bonds, all right, which are basically relationships between atoms, the subatomic players come into the picture, and those are electrons. So we've got the protons and the neutrons that are hanging out in the nucleus, and then we've got the electrons that are hanging out in the orbitals around the nucleus, and they are facilitating relationships between other atoms by way of bonding. And basically the reason why atoms get in relationships is because they bond to become more stable. They become more stable by filling their outer shell, either by losing electrons, gaining electrons, or sharing electrons. We've got three main types of bonds that we're going to talk about, four really total: ionic bonds, covalent bonds, which can be broken down into two different types: nonpolar covalent and polar covalent, and hydrogen bonds. So the difference between covalent and ionic is that in ionic there's a total loss or gain of electrons. So there's going to be a transfer of electrons from one atom to another, which is going to result in an imbalance of charges between the protons and the electrons, which is going to yield ions in the form of cations or anions. In covalent bonds, there is sharing of electrons, and in some instances there's equal sharing, so that that molecule is actually neutral in terms of electricity, and then electronegativity, excuse me, and then we have sometimes where there's unequal sharing, which will create some partial charges. So this is a little schematic that is showing ionic bonds. So this is an ionic bond between NaCl, which is sodium and chloride. So in this instance, sodium's got one electron out in that third shell, and it's much easier for it to give chloride that electron that fills chlorine's outer ring there, and so then everybody's happy. Everybody has their valence shell full. So sodium would become a cation, positively charged. It would be a +1 because it's just giving up one electron. And then chlorine would become -1 because it's gaining one electron. This is showing polar covalent bond. So here we have H2O. So we have this big oxygen and these two hydrogens. Well, oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer ring. It needs to get 8. Hydrogen has 1 to give. This hydrogen has 1 to give. So basically what's going to happen is that these electrons are going to hang out more with oxygen because oxygen is just larger. Okay, it's more mighty, if you will. So this creates a partial negative charge with oxygen and a partial positive charge with the hydrogens. So this is a polar covalent bond, unequal sharing of electrons. This is just a really quick slide about different patterns of chemical reactions. So basically we can either have synthesis reactions where we are combining two things together. We can have decomposition reactions where we're taking one thing and breaking it down into two different parts. And then we can have exchange reactions where basically partners end up switching. And we're not going to go into too much detail about that. Factors that are going to increase the rate of reactions. So we increase temperature, we're going to increase the rate of reaction. Increasing concentration of particles, so more stuff, more reaction is going to happen. If we cut particle size, I think about cooking, okay? So if you were to cook one giant carrot or one big piece of steak, okay? If you cook one solid object, it's going to take a longer time for heat to affect it. There's not as much surface area than if you chop that carrot up or chop that piece of steak up. There's going to be more surface area, so that overall is going to cook faster, and then the presence of a catalyst, and that is an enzyme. So you probably learned about in biology that enzymes lower the activation energy in order to start a reaction.